Describing data numerically. Definitions that you should know. The mode is the most frequently appearing value in a data set. The median is the middle value when it is arranged ascending or descending order. Or if it is an even number and you have two middles, you just average the two. Just do the mean of the two. The mean is the sum of the values divided by the number of the values. Okay, a couple things here. If you take stats in college, you're going to see this notation. So population mean. So think about the word population. Population means I took the whole thing and divided by all of it, right? The summation at the top means I took every single one of them and added them up, and I divided by how many I had. It is notated by the Greek letter mu. That's what this guy is, mu. And that is universal. So no matter where you take stats class, if you see mu, they're talking about population mean, okay? And very often that's all you're gonna get. And they're gonna go find, and they're gonna write that little Greek letter mu. And that just means average. That just means give me the mean. Sample mean is the X bar. So they just do the bar to distinguish it between like the variable X. But that means we didn't take the entire population, we took a sample and did the average of that to predict or whatever we might do with the sample. So that's the only difference. You're literally adding and dividing like you've always done for mean, okay? It's just notation looks different because it's like when you went from using the X for multiplication, then the dot, and then you now know if you have two variables together, it automatically means. So it's just graduating you to more advanced notation versus just them telling you to find it. Let's look at the first example, which hopefully we all know how to do. Find the sample, mean, median, and mode. So if I want to find my mean, which is typically the one that everybody automatically knows how to do, I'm just going to add them all up. I'm not going to show you how to add them up, but add them all up, you get 226. There are 11 total, and you're just going to divide. Depending on how they want it, you'll typically round this to a decimal. Median, that's the guy in the middle. In order to find him, they have to be in an order, either ascending or descending. It doesn't matter which. The order they gave it to me in is not acceptable. I cannot find my median doing it that way unless I bounce around. And so if you put them in order from least to greatest, you do have to list ones that are listed twice. You have to list them twice or three times, or however many times that they are listed. And then it's basically, I had 11, so my sixth term should be my middle term, right? And that's honestly all there is to it. So we're going to say, well, 20 should be my sixth value, so that is my median, the guy in the middle. And then mode is literally the one that appears the most. You can have none, right? If they all appear one time, then we don't have one. You can have multiple. If you have ones that appear the same number of times, above one, you can have multiple, or you can have one of them. In this case, we only have one mode. 24 occurs the most, so this guy is going to be my mode. So I would say my mean then is going to be 20.5, my median is going to be 20, and my mode is going to be 24. The term variance should be familiar to you. And it basically means the same thing in statistics, but they classify it numerically. So when you say variance, you could be talking about the same concept, but you don't think of it as a specific number set. And you will, when you're doing stats, it is a specific, you actually calculate the variance. And so when you look at this, values are spread out different ways. Range is something you probably already know. Range is your highest to your lowest. You subtract out and you figure out what that range is. You have variance and standard deviations. These are probably new. And then we're going to get into interquartile range later on in this same section. So how are the values spread out is really what we're looking for. Range we know, but when we look at deviation, we're looking at the difference from the mean or sample mean, which is, or population mean, depending on which one you're finding, to the average one of your terms or elements, okay? And so we have a standard deviation. So if you say something deviates from the norm, you know what that means. It moves away from, or is not exactly on the middle of the norm. But in statistics, you have a standard deviation, and there's actually a way to calculate. So the variance is the average of this, and the standard deviation hones in on what one deviation should look like. So to find the variance, we are going to take the squares of the deviations. So we're going to take each one of our numbers and subtract it, or subtract our average that we calculated, our mean that we calculated, and square it. And then you notice my little summation symbol here. I'm going to add them all up, and I'm going to divide. These are the same formula, right? You'll just notice that for this guy, we do n minus 1, and that's actually a proof that you will, if you take higher statistics, for those of you that just absolutely want to take tons of stats, this is a proof as to why they do an n minus 1. It actually gets you closer. But these are basically the same. If you did a population, you're going to do your actual count. If you do a sample, you're going to subtract 1 from your count. That's really the only difference. But you're taking the squares of the differences, adding them up, and dividing. Standard deviation takes whatever number that you just did and then does the square root, okay? And so those are the formulas. They're basically the same. Just pay attention to the denominators and know whether they're giving you a population or whether they're giving you a sample. So let's look at the example. Calculate the sample variance and standard deviation for the set 2, 4, 6, 8, 10. So before we can do anything, we have to know the mean, all right? Because that's what all of this is calculated on. So before I do anything, I'm going to add all of these up, 2 plus 4 plus 6 plus 8 plus 10. I'm going to divide by 5, and I am going to get that mean of 6, all right? So all I did was find my mean, my sample mean. And then you'll notice that they made a chart. So they took each one of these and they subtracted that mean and squared it. Subtracted the mean and squared it, right? Did all of that. And then to find the sample variance, we need to total that because it's a summation. So we total it to get the sum. So when you add all those up, so we're going to add them all up, right? And we're going to get 40, all right? The sum of the squares. And then we're going to take that. This was a sample. So we are going to take the 40, and we had 1, 2, 3, 4, 5. We need to divide it by 5 minus 1, okay? And so we're going to get that the sample variance was 10. So when they ask for sample variance, we are going to summation of each one of my guys, that's why it's I, each one of them, minus the mean that I found, square it, and for sample, we're going to divide it by our count minus 1. So that's how we got 10 for my variance. Once you have him, standard deviation is just the square root. Like standard deviation is literally going to be the square root of that. And so we're going to say my standard deviation is going to be the square root of 10. Typically, you're going to actually round this guy, so they'll tell you. I mean, 2's fine, but they'll usually tell you. So you're not going to leave it as square root of 10 because you're going to then take this guy and see how far off things are, and square root of 10 doesn't give you a lot of information, but 3.16 does, right? So they want us to do a frequency distribution here. basically what we're doing is we're doing exactly what we did. We're just going to list all the scores one time and tell the frequency as well. And then we're going to calculate our mean, our variance, and our standard deviation. You just did it for like 5 of them, right? So as you can see, this is more than 5. And I don't want to do that many times, right? And so what we're going to do is we're going to create a spreadsheet and we're going to do some formulas. I just want to make sure that everybody knows how to do spreadsheets, formulas, etc., and do some calculations with them, okay? So we're going to open a spreadsheet. I want you to type the scores in, not according to this right here. So I'm going to actually cover him up because you're going to be tempted to do that. I want you to put them in like this. And if it lists it more than once, you're going to just put it one time and how many times it's listed. So it's in order for us, which is nice. But you're going to say 73, and then you're only put 75 one time. And then you're going to have a column with frequency. So I'm going to pop the column up here so you can see it. Get through it. All right, so this guy is called a box plot. And so typically what they do is they take your list of information and they divide it into quarters containing the same amount of data, all right? So you'll notice that it doesn't look like it's the same, but that's because you have your score range at the bottom. The count is what's the same here, okay? And so you have 4 quarters going on. You have the first quarter, the second quarter, the third quarter, and the fourth quarter. All right. You'll see this when you get a standardized test results. You'll often see these types of things. All right. And that kind of tells you where the middle of the distribution is and versus like, and they'll actually show where you fall versus the middle of the distribution as well. And so these are called like box and whiskers. Did they tell you that on here somewhere? These are called whiskers, right? I don't know. Maybe because it looks like a cat. I'm not sure. But so they kind of tell you what would fall in the middle here and then what falls out here. And so this is how you start to look at what's called outliers. All right. And so when I look at, for example, they give you this example right here. An outlier is something that's actually a specific amount away from your the rest of your information. And so we'll do some calculations later. But when I look at this, I am going to automatically assume something. I'm going to assume that 25 is an outlier, okay? And so what the outliers do is they skew your information. So if I look at the mu or the mean of this information with that guy in it, it's 60.2. When I look at it without it, 63.4. That's actually a significant change in from one to the other, considering it with my outlier or considering it without. And they're actually trying to figure out, is this an outlier? And so they look at the median, 61.5. They look at the median here, 62. And then they look at their quarters. So they average the quarters with and without. And we have this number that they have come up with, 7.5 and 9. And so then they look at their quarters and subtract it out and say, did it affect it enough? It affects it at a 1.5 rate, then it's considered an outlier. So I'm not worried about you calculating how to tell if it's an outlier at this point. I want you to understand what it does to your information when you have one, okay? So if I were to look at a neighborhood and they were to say the mean range of homes is this, but you have 2 homes sitting on the water that are worth 1.5 million and the rest of the neighborhood is 400,000. We're going to knock those 2 houses out before we give someone that information. Does that make sense? And so that's what we're doing with stuff like this.